Hello everyone, this is Abhishek Mahanti and I welcome all of you to my class. So today we'll start the first chapter of the class 12 physics syllabus, and the chapter name is electric charge and field. But before starting this chapter, let me give you an idea of your physics syllabus. So you have total 2 books, volume 1 and volume 2. In volume 1 there are total 8 chapters and in volume 2 there are 6 chapters. So in this year you have to cover 14 chapters. So volume 1 is all about electricity and magnetism. Just look at the names of the chapters. The first 2 chapters are known as electrostatics. So electrostatics means what? Electro refers to charge, statics refers to something at rest. So in the first 2 chapters we will discuss about or will study the behavior of charges which are at rest, like the force between 2 point charges, electric field, electric potential, electric field lines, electric flux, and there is a very important law known as the Gauss law and capacitance. So all these things will be covered in the first 2 chapters. Then come to chapter number 3. It is about electric current. So in class 10 you have already studied about electric current. What is the meaning of electric current? How does the electric current flow in a circuit? What is the function of a battery? What is potential difference? Then what is resistance in series, in parallel, electric power, electric energy, all those things you have already studied in class 10. So in class 12 we will again study all those things and we will also discuss something more. Then come to chapter number 4. The name is moving charges and magnetism. So in this chapter we will discuss about the magnetic effect of charge or the magnetic effect of electric current. So when a charge moves, it produces a magnetic field. So that is the theme of the chapter number 4. Then in chapter 5 we will discuss about the magnetism and matter, means the magnetic field due to a bar magnet, the magnetic field of earth, and the different types of magnetic materials like diamagnet, paramagnet and ferromagnet. Then come to chapter number 6. The name is Electromagnetic Induction. So in this chapter we will discuss about how can we get an EMF or a voltage from the magnetic field. In chapter number 7 we will discuss about alternating current or AC. Chapter 8 is about electromagnetic waves, means how can we produce electromagnetic wave, what are their uses and what are the frequency range of different types of electromagnetic waves. So volume 1 is all about electricity and magnetism. Then come to volume 2. The first chapter of volume 2 is about ray optics. In class 10 you have studied about reflection, refraction, the spherical mirror, spherical lens, prism, and all these things. So we will again discuss about those fundamental things. Then we will also discuss about some more information, some more data like the simple microscope, the compound microscope, telescope, all those things will be covered in ray optics. Then come to chapter number 10. It is about wave optics, means there are few phenomena related with light which can be explained on the basis of wave nature of light, like interference, diffraction, polarization. So all those concepts will be covered in chapter number 10, means in wave optics. Then come to the next chapter, dual nature of matter and radiation. So in this chapter we will discuss about the dual behavior of matter as well as radiation. So we know that light behaves as a particle as well as a wave. Similarly, every matter has a wave property. So all those things, means the dual nature of matter as well as radiation, will be discussed in this chapter. Now come to the chapter number 12, atoms. So in this chapter we will talk about the atomic structure, the atomic model given by Rutherford, given by Bohr, and all those derivations about the radius of the orbit of electron, the energy of electron, all those things. Then in chapter 13 we will discuss about nuclei, means the constituent of nucleus, the nuclear force, the binding energy, the packing fraction, the mass defect, radioactivity, all those things. And the last chapter is very interesting one. It is about electronics, and we'll discuss about semiconductor. We know that the materials can be divided into three categories based on their relative values of resistivity or conductivity. So the three categories are metals, non-metals and semiconductors. Metals, insulators and semiconductors. So we'll discuss about the semiconductor physics in the last chapter. So in this year you have to finish or you have to cover all these 14 chapters for your annual board examination. So today we'll start the first chapter of this physics syllabus, which name is electric charge and field. So I hope you have understood what are the chapters you have to cover in this year. So let's start the journey with new excitement and new energy. So in this chapter we'll discuss about what is the meaning of charge, what are the properties of charges and how to electrify a body. So the first question is, what is the meaning of charge or how can we define a charge? So in lower classes we have some idea about charge, but if you want to write the definition, then how can you write it? The definition is, it is the fundamental property, it is the fundamental property, it is the fundamental property of every matter, due to which it produces and experiences various electrical and magnetic effects. So students, remember that charges are the fundamental property of every matter. In the universe, every matter is made up of charges. So charge is present in every matter. And what is the effect of this charge? So due to the charge, we can experience or we can exert or we can produce various types of electrical and magnetic effects. So remember that charge is responsible for electric as well as magnetic effect. But in the first two chapters, we will limit our discussion to the electric effect of charge. In chapter 4, we will discuss about the magnetic effect of charge. So our discussion is limited to the electric effect of charge in the first two chapters. And you know that charges are of two types. One is positive charge, the other one is negative charge. So I can write that charge is of two types. One is positive charge and the second one is negative charge. Can you give me example of a positive charge and negative charge? Yes, you know that protons are positive charges, electrons are negative charges. If we consider an atom and if you look inside the atom, then we have a nucleus. Inside the nucleus we have protons and neutrons. Neutrons are neutral, means they carry no charge, but protons carry positive charge. And around the nucleus we have electrons which are revolving around the nucleus in different orbits, and the electrons carry negative charge. So the simple example of a positive charge body is proton and a negative charge is electron. So let me write the example here. Protons are positively charged particles and electrons are negatively charged particles. And remember that charge is a scalar quantity. We can measure the amount of charge present on a particle or present on a body. Means charge has magnitude but it does not have any direction. So charge is a scalar quantity. Charge is a scalar quantity. Means it has only magnitude. So there must be some unit by using which we can measure charge. So remember that the SI unit of electric charge is coulomb. The SI unit of electric charge is coulomb. Is that clear? The SI unit of electric charge is coulomb. And we will discuss about the series unit in the upcoming classes, but remember that the SI unit of charge is coulomb. So now tell me, what is the value of charge on a proton and what is the value of charge on an electron? Remember that the charge of proton is plus E and the charge of electron is minus E. Charge of proton is plus E and charge of electron is minus E. We know that electron is negatively charged and proton is positively charged. So you can see that the magnitude of charge on proton is same as the magnitude of charge on electron, but they have different polarity. Proton is positive, electron is negative, but their numerical value is same. So what is the value of this E? E is 1.602 into 10 to the power minus 19 coulomb, or you can write 1.6 into 10 to the power minus 19 coulomb. So the charge of proton will be plus 1.6 into 10 to the power minus 19 coulomb and the charge of electron will be minus 1.6 into 10 to the power minus 19 coulomb. So protons and electrons, they carry equal amount of charge, but they have opposite polarity. Proton carries positive charge and electron carries negative charge. And remember that in an atom we have same number of or equal number of protons and electrons. In an atom we have same number of protons and electrons. For example, if I consider a carbon atom, we know that the atomic number of carbon is 6. Z is equal to 6 for carbon atom. It means inside the carbon nucleus we have 6 protons. Inside the carbon nucleus we have 6 protons, and outside the carbon nucleus 6 electrons are revolving around it. So if you look at the carbon atom, there are 6 protons and 6 electrons. 6 protons and 6 electrons. So if you want to find what is the total charge, what is the net charge carried by a carbon atom, the answer will be 0. How? We have 6 protons, and each proton carries charge of plus E. So what is the total positive charge? The total positive charge will be 6E plus 6E, and there are 6 electrons and each electron carries a charge of minus E. Electrons carry negative charge. So a single electron carries a charge minus E, and we have 6 electrons in carbon atom. So the total negative charge will be minus 6E. The total positive charge is plus 6E and the total negative charge is minus 6E. Now if you want to find the total charge, the net charge, then you have to add the total positive charge and the total negative charge. So plus 6E and minus 6E will cancel each other. The answer will be 0. Means in an atom we have charged particles, but the atom as a whole is electrically neutral. Remember this statement. In every atom we have charged particles. We have protons and electrons, but the net charge of an atom is 0, because in every atom we have equal number of positive and negative charges. We have equal number of protons and electrons. So although every matter around us consists of charged particles, but they are neutral because they carry equal amount of positive and negative charges. Is that clear? So this is all about the meaning of charge, the types of charge and the unit of charge. Now we will discuss about some basic properties of charges. We have to discuss about some basic properties of charges, or the fundamental properties of charges. So the first property of charge is the additivity or additive nature of charge. Properties of charge. Properties of charge. The first property is additivity. Additivity, or you can write that additive nature of charge. Additive nature of charge. So additive nature meaning what? It means that suppose in a body we have multiple charges at different locations. Suppose this is a body, and on the body we have different charges at different locations, at different points on the body. Suppose at this point I have a charge Q1. Remember that Q is the symbol for charge. You can write small q or you can write capital Q. Suppose at this point we have a charge Q1, at this point I have a charge Q2, at this point I have charge Q3, and at this point I have charge Qn. So there are total n number of charges present on the body at different parts of the body. Now if I ask you to find the total charge on the body, I'll ask you to find the total charge on the body, then the answer will be Q total. Q total is equal to the algebraic sum of all the charges present at different locations of the body. Means you have to add all the charges which are present on the body. So the answer will be Q total equal to Q1 plus Q2 plus Q3 plus Qn. We know that charge is a scalar quantity. So whenever you are adding the charges, you have to add them like normal numbers. But remember one thing, when you are adding the charges, you have to also mention their polarity, their sign. The charge may be positive, may be negative. For example, the value of Q1 is 1 microcoulomb, value of Q2 is minus 2 microcoulomb, value of Q3 is, let us say, 5 microcoulomb. Suppose in this body we have 3 charges. Okay, Q1 is 1 microcoulomb, Q2 is minus 2 microcoulomb, and Q3 is 5 microcoulomb. Means at 3 different locations I have 3 charges. The total charge of the body will be Q1 plus Q2 plus Q3. Q1 plus Q2 plus Q3 means 1 microcoulomb, then plus minus 2 microcoulomb plus 5 microcoulomb. So 1 microcoulomb plus 5 microcoulomb will be 6 microcoulomb, then plus minus will be minus 2 microcoulomb. The answer will be 4 microcoulomb. So when you are adding the charges, you have to also mention their signs. The charge may be positive, it may be negative. So this is the additive nature of charge. Means the total charge on a body is equal to the algebraic sum of charges present at different points of the body. So let me write the definition of this additive nature. You can write that the total charge on a body is equal to the algebraic sum of all the charges, algebraic sum of all the charges present at different points, of the body. The total charge on a body is equal to the algebraic sum of all the charges present at different points of the body. And mathematically you can write that Q total is equal to Q1 plus Q2 plus Q3 dot 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 Qn, or I can write that Q total equal to sum over Qi, sum over Qi, I equal to 1 to n. Means if you put I equal to 1, you can write Q1. If you put I equal to 2, you'll get Q2. If you put I equal to 3, you'll get Q3. And if you put I equal to n, you will get Qn. And this symbol means summation, sum of all these charges. So this is the first property of the electric charge, and the property is additivity or additive nature of charge. Now we'll discuss about the second property of charge, which is the discrete nature of charge or quantization of charge. The second property is a very important property. It is known as the quantization of charge. Quantization of charge. So what is the meaning of this term, quantization? Quantization. This quantization comes from a word known as quantum. Okay, quantum means what? The small packets. Small packets. Is that clear? So what is the meaning of this property or this nature of charge? Remember that we know that the unit of charge is coulomb, but remember that the smallest amount of charge, that you can get is the charge of electron. The smallest amount of charge, which exists freely, is the charge of electron, which is E, and the value of E is known to you, which is 1.6 into 10 to the power minus 19 coulomb. So this is the smallest amount of charge which exists freely in nature. Means if you break electrons, then you will get quarks, and the quarks have charge which is again less than E, but the quarks, they don't exist independently, or they don't exist freely. So the minimum amount of charge which exists freely is the charge of electron. Is that clear? So when a body has some charge, I had told you that in an atom or in every body we have charges. In this pen I have charges, we have charged particles. In my body I have charged particles. On this board I have charged particles. But this pen is electrically neutral, my body is electrically neutral, and at the same time this board is also electrically neutral. Why? Because in every atom we have equal number of positive and negative charges. So atom is electrically neutral. Now the question is, how to electrify a body? So as long as the number of protons and electrons are equal, if the number of protons and electrons in a body are equal, the body will be neutral. So in order to electrify a body, or in order to charge a body, you have to imbalance the number of protons and electrons. Is that clear? So again I am repeating the statement. In order to electrify or in order to charge a body, you have to imbalance the number of protons and electrons. And how to do it? Either you remove electron from the body or you supply electrons to the body. Either if I remove electrons from this pen, or if I supply some extra electrons to the pen, then this pen will become charged. Now you can ask the question that why should we remove electrons? Can we remove protons? In order to charge a body, you have to imbalance the number of protons and electrons. So if you remove protons from the body, then also you are imbalancing the number of negative and positive charges. Can you do it? The answer is no, because protons are situated at the center of the atom inside the nucleus. So to remove the protons we need a very large amount of energy, which is not available to us. Means in our home we cannot get that amount of energy. If you set up a laboratory, then you can get the large amount of energy, but in day-to-day life we cannot supply that amount of large energy so that we can remove protons from a body and will electrify it. But electrons, they are outside the nucleus, they are revolving outside the nucleus. So it is easier to remove electrons than to remove protons. Is that clear to all of you? So remember that by removing electrons or by supplying electrons to a body, you can electrify it or you can charge it. So if you have a body and this body has equal number of protons and electrons, then the charge is 0. Suppose this body has equal number of protons and electrons, then the charge will be 0. Now if I remove one electron, from this body, then the body will have a positive charge, because suppose imagine that initially there are 100 protons and 100 electrons. Okay, suppose initially there are 100 protons and 100 electrons inside the body. Now if I remove one electron, then we will get 99 electrons. If I remove one electron from the body, then I will have 99 electrons inside the body, but we have 100 protons. We are not removing protons, we are removing the electrons. So if one electron is removed, the number of electrons decreases. Now you can see that the number of electrons and number of protons, they are not equal. Number of positive charge is more than number of negative charge. It means the body will acquire a positive charge. So if one electron is removed, then the charge on the body will be plus E. The body will acquire a positive charge. And what is the charge? Plus E. If you remove two electrons, the charge will be plus 2E. If you remove 3 electrons, the charge will be plus 3E. If you remove 5 electrons, the charge will be plus 5E. If you remove 100 electrons, from this body, the charge will be 100E, plus 100E. So what do we observe from this data? So we can remove either 1 electron or 2 electrons or 3 electrons, means whole number of electrons. You cannot remove 1.5 electrons. You cannot remove 3.4 electrons. Means we cannot remove fractional number of electrons. We can remove whole number of electrons, either 1 or 2 or 3 or 4 or 10, 15, 20, such type of electrons. Fractional number of electrons cannot be removed. So since we cannot remove fractional number of electrons, so the charge of the body is always a whole number multiple of E. Either you have 1E or 2E, 3E, 5E or 10E, 15E, like this. Similarly, if you supply electrons to the body, then the number of negative charges will increase. The number of electrons will be more than number of protons. Means the body will acquire a net negative charge. Is that clear? The body will acquire a net negative charge. If you supply 1 electron, then the number of electrons will become 101. We will get 101 number of electrons, but we have 100 protons. So the body will acquire a negative charge. The charge will be minus E. If you supply 2 electrons, then the body will have 102 number of electrons. So the net charge will be minus 2e. If you supply 10 electrons, then the total number of electrons will become 110e, and the net negative charge will be the net charge of the body will be minus 10e. Is that clear? So again you can see that the coefficient of E is a whole number, is an integer. It cannot be a fraction. The coefficient of E cannot be a fraction. It cannot be 2.3, it cannot be 3.7, it cannot be 4.5, like this. The coefficient of E is always an integer, always a whole number. So I can say that the charge of a body, means Q, is always an integral multiple of E, is always an integral multiple of E, means Q is equal to NE. What is N? N is an integer. N is an integer, means N can be 0, it can be plus minus 1, it can be plus minus 2, plus minus 3, and so on. But N can never be a fraction, because we cannot remove or we cannot add fractional number of electrons. We always remove or we always add whole number of electrons. So Q is always an integral multiple of electronic charge, or Q is equal to NE. So this is the mathematical statement of this property, quantization of charge. So I can write that the charge of a body, is always an integral multiple of electronic charge. Integral multiple of electronic charge means Q is equal to NE, where N equal to 0, plus minus 1, plus minus 2, plus minus 3, and so on. But N can never be a fraction. If N equal to 0, the body is uncharged, the body is neutral, because if I put N equal to 0 here, then Q will be 0, means the body is uncharged. And if you put if you put N equal to plus 1, the charge will be plus E, means the body is positively charged. Okay, so this is the meaning of the quantization of charge. Now let me ask you a question based on this concept. The question is, can a body hold 6.8 into 10 to the power minus 19 coulomb of charge? The question is, can a body hold 6.8 into 10 to the power minus 19 coulomb of charge? So how to determine whether a body can hold this amount of charge or not? So this is the amount of charge, means this is the value of Q, and we know that Q is always an integral multiple of E. So this charge should also be NE. So Q equal to NE, that implies N is equal to Q by E. N is equal to Q by E. So if the value of N is an integer, then yes, the body can hold this amount of charge, because I had told you that N is always an integer, it can never be a fraction. So if in this question we will get a integral value or a integer value of N, then yes, the body can hold this amount of charge. But if N is found to be a fraction, then the body can never hold this amount of charge. So now let us find the value of N here. So N equal to Q by E. So what is Q? 6.8 into 10 to the power minus 19 coulomb. And what is E? E is 1.6 into 10 to the power minus 19 coulomb. So they will cancel each other. Now we have 6.8 by 1.6. Okay, so you know that 1.6 into 4 is 6.4 and 1.6 into 5 equal to 8, but this value 6.8 lies in between 6.4 and 8. It means if we divide 6.8 by 1.6, then the answer will be 4 point something. Is that clear? Means we are getting a fractional value of n. Here n is not an integer. Since n is not an integer, it is not a whole number, so a body can never hold this amount of charge. If instead of this value, if I will ask you that whether a body can hold this amount of charge, then the answer will be yes, because if I find n in this question, then this is Q, E is 1.6 into 10 to the power minus 19 coulomb, and then they will cancel. So 6.4 by 1.6 will be 4. Means if a body will lose 4 electrons, the charge of it will be this much. But a body can never lose 4.3, 4.7, 4.5 electrons. Either it will lose 4 electrons or 5 electrons, not in between them. That's why a body can never hold this amount of charge. So this is the meaning of quantization of charge. Means charge of a body is always quantized, always an integral multiple of E, where E is the electronic charge, and that n can never be a fraction. Means there is a minimum amount of charge which exists freely. So this is the second property of charge. Now we will talk about the next property, the third property, which is the conservation of charge. Conservation of charge. The third property is conservation of charge. So what is the meaning of conservation of charge? Again, conservation of something means that quantity can neither be created nor be destroyed. Similarly, you can write that charges can neither be created nor be destroyed. In an isolated system, the total amount of charge is fixed, is constant. Charges can be transferred from one body to the other body, but you cannot destroy charge. You cannot create new charges. They can be transferred from one body to the other body. So let me write here that charges can neither be created, charges can neither be created nor be destroyed. They can only be transferred. They can only be transferred from one body to another. They can be transferred from one body to another. In an isolated system, the total charge is conserved. The total charge is conserved, means constant. Means you cannot destroy a charge particle or you cannot create a new charge particle. What you can do? You can just transfer the charge from one body to the other body. Okay, you can never destroy it or you can never create a charge. So these are the three basic properties of electric charge. The first one is the additive nature or additivity of charge. The second one is the quantization of charge. The third one is the conservation of charge. So hopefully you have understood all these concepts. What is the meaning of charge, the units of charge, and the types of charges. Then we discuss about the three basic properties of charges. Now the next topic is how to electrify a body or how to charge a body. So there are three methods. There are three methods in which we can electrify or we can charge a body. The first one is by the method of friction. The second one is by the method of induction, and the third one is by the method of conduction. So there are three methods in which we can electrify a body. So in the next class we will discuss about these three methods by which we can electrify a body. So hopefully you have understood all the things that have been discussed in today's class, and we will meet in the next class with new topic. Till then, bye bye.